Hello, everyone. Today, I will be taking you through moving to MAS and the impact of the new infrastructure model. My name is Troy Elsen, and I'm the Director of Cloud Infrastructure at ProjTech. And for a little background on me, I've been with ProjTech for around 11 years working on our Maximo offering. During that time, I've worked on implementation projects, partner onboarding, but mainly the continuous improvement of the solution stack that powers our Maximo as a service offering. On this first slide, we've got this MAS 8 platform change slide that shows Maximo 7.6x next to MAS 8. Mind you, this is very focused on the Maximo we know today, so the managed namespace, as opposed to the entire suite of apps that come with MAS. As you can see, that blue box up in the top of both diagrams looks pretty similar to each other. And that's really because the managed namespace is encapsulating the Maximo we know today. So there's not a ton that's changing there. There's going to be some skin changes, some buttons that were on one side of the screen might be moved to the other. You might have to click a different drop-down to get to some menus, stuff like that. Nothing too complicated, no huge functionality changes, though, inside of the manage application. And as you can see, that Maximo data is also still going to be stored in a standard SQL, Oracle, or DB2 database. Really, where we're going to see the big changes are going to be below that, outside of the Maximo application. So in today's world, we have a lot of VMs or bare metal. Maybe you're running Liberty containers or Liberty servers running your Maximo application. Typically, it's looking like it's going to be web server network deployment. So that's that green box, that web server application server. It could be a real Windows box. It could be a Linux box. But that's really housing where a lot of your functionality is. So that's where you're clustering your application servers. That's where you're setting up your web server tie-in. So your IIS or your IHS or ODR, or whatever you're using for that component. It's where you're setting up your authentication if you're using LDAP or SAML, and letting those users kind of flow through there. Message queues, logging, all of that's happening at that web server level. A lot of that is getting moved over into the platform, the container runtime that is OpenShift from S8. And as you can kind of see, there's a few new components that are added in. So we've got the MAS core namespace, and that's going to really be handling your authentication, your LDAP integration, your SAML, some of your core components, and that's going to be reaching out to its own database provider, which is the Mongo database. As you can see out to the side there, there's the Kafka message queues, and that's a little bit new. You still have some of your basic simple JMS that you can run as a separate bundle, a server bundle for the managed deployment, but a lot of people are switching to actually using message queue services. So it's another external component. And as you can see under the managed namespace, a lot of that is being encapsulated in the OpenShift platform. So that's where all your high availability, your clustering is going to come from. That's what's handling those inbound traffic routes to actually route stuff to your applications. As you can see, there's a few other components here. There's a Suite license service where you're going to upload your license key, and it's going to manage your app point usage and kind of reporting on that. There's the MAS core namespace that encapsulates a bunch of stuff as well. Here we've got the authentication, so LDAP integration, SAML, and you can kind of see that those actually reach out to other components as well. As you can see, the Mongo database is connected to both the MAS core namespace as well as the Suite license service. The other one that being over in that box is the Kafka message queues. We have those over in a separate container runtime on this image. Those can run inside of OpenShift as well. That's really going to be a deployment preference on your side. As you can see, there's some log aggregation as well that's coming outside of the platform. And that's really aggregating all those logs from all those different namespaces and then allowing you to send those out to a SIM or like an Elastic instance or something along those lines. So why the switch? Why the switch to containers? Why the switch to OpenShift? And really it's around these topics here. So consistency, scalability, portability, and then change in mindset and skill set. And those are really going to be the things that I'm going to delve into here. As you can see on the image to the right, it kind of shows some of the lifecycle management for, or lifecycle phases for OpenShift and kind of the operators. And really, we're operating in like the phase 1 to 2. The goal is to get to full autopilot, right? So the application can update, it can scale up with load, it can scale down. You get full insights into what it's doing, metrics and alerts on when things are failing, when things are scaling. Knowing when things are happening is good. Then that's really the goal, is to get to that full lifecycle management, then get into more of the insights, and then into autopilot. All right, so the first one is consistency. And consistency is kind of paired with resiliency in my mind. So the first big thing here is containers, right? Why containers? Containers allow for faster startup and availability. They're smaller sets of binary that you're not loading as much into memory as it's coming up, as if you had a full VM that you're reloading. It also allows you to decouple some of the dependencies. So you can upgrade stuff. You can upgrade certain components of your stack without impacting other pieces of infrastructure. You can also decouple things that have shared services. So let's say you have multiple things that use Mongo. Right now, you can have multiple Mongo pods that are all running different variations and versions of Mongo to kind of appease each individual situation. The other thing to keep in mind is as you upgrade Mass Core, for instance, it doesn't create an outage. Mass Core was developed to be on this platform. So when you set it to upgrade, it actually spins up the new version of Mass Core and migrates to that and shuts down the old one seamlessly. So there's really no outage of that service. That's that full autopilot, full life cycle that we're trying to get to. Manage updates right now do create an outage. We still have some dependencies on update DB and different things like that that really require the application to be down for those activities to run before bringing that new version up. The next thing that we're going to talk about is operators. Operators, as you can see here, that has deployments. That's what it's kind of they're made up of. Allows for some health checks and some lifecycle management. But inside of an operator, we can actually set up like custom resource definitions for all the workload that's underneath that, giving it the min and max, the requests and limits for those pods. As they spin up, they kind of get their own resource allocation. Maybe they have a GPU, maybe they don't, different stuff like that. It allows us to manage state of those workloads. So one of the big things, the big shifts here is kind of desired state management. So instead of us being able to just change stuff hot and that becoming the new running config and we can restart the VM and everything's going to come back up the same way, everything is managed from a state perspective back to that initial deployment. So when you want to change how much memory you're giving a JVM for a heap, you're actually modifying it at the deployment level or at the operator level and then redeploying. And what that does is it really keeps consistency in your state of your application. Someone can go in and hot change those things, but these operators are actually going to go and overwrite those settings to get the workload back to desired state, which is a really key concept to keep in mind. The other thing to keep in mind is some scalability options that come in there, replica sets, which allow us to have kind of like hot, cold workloads set up, deployments, which really, like I said, kind of lay out the entire deployments that really lets you lay out the entire deployment strategy for your application. And that allows you to actually deploy that same workload in OpenShift in any location pretty much consistently, which is really key when it comes to these workloads. Next, we're going to talk about scalability. So scalability, there's service level scaling. So due to us doing that containerization of applications and of components, and we've decoupled all those from each other, so we've kind of got this nice segmentation between all those different services, we're actually able to scale different ones when we see fit. So maybe you have a high integration load and you need to scale just that portion of your stack up. And we've been able to do this in previous iterations of Maximo on WebSphere, setting up new JVMs and stuff. The thought process here is that this is going to make it a lot easier. The ephemeral nature of containers is really what IBM and what the Maximo teams are leaning into to get to where we can scale those services up when we have high peak load and then scale them down afterwards so that you're not over allocating resources for those one-off moments in time where you have all those integrations hitting your system. This is all kind of handled through server bundles today. I kind of mentioned the requests and limits. So when you build a server bundle with your JVM counts of all your different types, each of those are going to have requests and limits on memory and CPU. You're going to kind of allocate those as such. Hopefully in the long run, we'll be able to do some more in-depth scaling. OpenShift has a lot of functionality to allow us to both scale the platform. So with machine sets and worker pools, actually being able to scale out into more compute as our application needs grow, but also being able to do auto scaling at the application level. And that would mean scaling, let's say, the MIF JVMs, the number of pods that we have for the MIF up from 2 to 6, let's say, when we have high load, and then back down to 2 when we don't have high load. Maybe JVMs related to mobile applications. We can scale those up when we have mobile users coming in back from the field at the end of the day, letting all of those mobile devices synchronize all their changes back into the system. And then, when the next shift starts, synchronize the data out, they go out in the field and those mobile pods scale back down. So there's a lot of functionality in the platform that as we kind of lean into the platform, we're looking to take advantage of. So the next topic is portability. So as the technical architecture of today's software products change, we see that more platforms are opening up to us. Traditional IT was always on-premise. You had your data center in your basement. As we worked through virtualization and as we've worked through now containerization, we see the adoption of more diverse platforms. So there is still the on-premise or private cloud option where you can run it in your own data center. You can run it in your own private cloud. There's now the public cloud option, which has been around for a long time, using a hyperscaler like AWS, Azure, IBM Cloud, one of those partners to kind of get your own virtualized public cloud footprint set up. Spin up your workers out there, spin up your master nodes to do your control plane, and you're off to the races with OpenShift. Then there's some hybrid, right? So you could do, maybe you have a requirement that you need to run OpenShift on premise. You can do that. It's kind of a blend of the two above. So on premise and private cloud and public cloud, you could do a public cloud offering that then has a DR into a local data center. You could do a local data center or private cloud option that then DRs out into public cloud. Really, the point of portability is all of these are options, right? All of these are at your fingertips. It just depends on how you want to deploy and what you're comfortable with doing. And then we have anything as a service or XaaS, and that's really blending all the choices above. Kind of going back to that first diagram, there's a lot of services. You don't have to run them all together. You don't have to containerize them all. You don't have to virtualize them all. As we kind of move into this next frontier, utilizing SaaS offerings for components or for the entire offering is something that's very viable for many corporations. So really kind of leaning into that cloud first mentality and thinking about how are we deploying apps and how do we want to support these? What pieces are we able to support? What pieces can we hand off to another team to support for us? So next we're going to talk about mindset change. So mindset change, how do we get into the same mindset as how things are being developed? And really what that's going to be is getting into a cloud mindset. And I know, bear with me, I just mentioned on the last slide that local private cloud or local data center is still an option. And it is. But in today's world, and as we continue to progress forward, things are being developed with a cloud first mentality. That means everything is being planned and built to be run in an AWS, in a hosting provider's data center, in IBM Cloud, in Azure, to name a few. That is what developers are building their applications for. And then they will run inside of an on-premise solution if you build it to support that type of workload. Really what this is about, though, is building our applications to run anywhere. right? We want to be able to pick our Maximo up, whether it be on premise today or if it's out in a cloud today, and move it to another cloud. This is really leaning back into that portability option. As we think about our mindset, we have to be thinking about how do we want our application to scale? How do we want our application to recover from failure? How do we want our application to run for our teams that are globally spanned? The next piece of that is going to be, as we build this platform, how are we going to build stuff around it, right? So what is our development team's lifecycle going to look like, and how are they going to build stuff that is in line with the platforms that our applications, third-party applications, are going to? And really that's around a microservice architecture. A lot of corporations have already kind of taken this on, have kind of made this their go-to-market strategy, have made it their mandate to their dev teams, but really that's that breaking apart of an application into its smaller components, separating those components out into their own workloads, into their own namespaces, and then scaling them as such. And that's kind of what I think we're seeing here with the application suite as we look at the other applications. As we look at visual inspection and monitor, et cetera, those are being separated out with their own dependencies, their own workload, into their own namespaces as we deploy them. So the big thing to keep in mind, though, with microservice architecture, as we do separate these things, as we deploy these other applications, it's just more stuff that we are supporting, right? You're now just supporting manage and all of its dependencies, monitor and all of its dependencies, MVI and all those dependencies, understanding the intricacies of all of those dependencies and where your team can specialize versus using a third party or hiring support contracts to maintain those is going to be key for your success. All right, so next we're going to talk skill set change. So as I kind of mentioned, OpenShift is the new platform, and there's going to be a lot of change in how you manage your workload on that platform, how you manage persistence, and how you look at monitoring. You're supporting all of those different microservices, right? And really figuring out what your level of understanding of each of those as you deploy them, as you support them, as you maintain them is key. And it's going to be key as you look to troubleshoot them when anything goes wrong. Fingers crossed, nothing ever goes wrong, but with technology, we always know you have to be ready. So one of those big things that is key to understand is going to be persistence. Understanding persistence on a container platform is huge because containers are meant to be ephemeral. They're meant to be turned off. They're meant to be thrown away and restarted from that base config that we talked about earlier. So understanding how you keep the data from those containers, from those workloads that you want, and pipe that out into persistent volumes maybe. We talked about manage keeping that SQL, Oracle, DB2 database, right? So where is your data actually persistent and where is it not? And understanding that. Secrets inside of OpenShift are another one that you need to make sure that you have. And really that's going to be around business continuity, backup recovery, and those type of activities, as well as if you want to move those applications from platform to platform. That's really where persistence becomes key. Kind of dovetailing off of persistence is monitoring, right? Not only do we need to make sure that we're keeping the things that we need to keep, but we also need to know when stuff's going wrong. As we mentioned, the ephemeral nature of containers, while it does impact persistence, it is also going to impact your monitoring, right? Having something going up and down is never good to see in your monitoring system, but you want to know when it happens. So making sure that you're able to kind of monitor that, but then also understand that, let's say when we get to these scalable sets, that stuff can scale up and scale down. How do you monitor for those use cases is going to be key. Mention log management, making sure that those events are all getting rolled out of OpenShift and into something like a SIM or an Elastic instance that you can actually do some data correlation on that. And then the other thing is monitoring your licensing. So I kind of mentioned and barely touched on that license service, the Suite License Service, SLS, but really managing those entitlements, managing those app points, making sure that you're not over consuming and that you're staying in compliance with what you have purchased and put into your license key. The next thing is going to be monitoring the OpenShift environment you're running, as well as what else is running on that OpenShift environment, right? So it's not just about your licensing and stuff like that. It's the entitlements that are coming with that licensing. You're entitled to run Maximo on OpenShift. As you start to lean into that platform, I can promise you're going to find some great tools when you're looking at monitoring, when you're looking at DR, when you're looking at business continuity, those type of activities. You're going to find a lot of tools that look fantastic, and making sure that you are still staying in compliance with your entitlements for the OpenShift platform is going to be key. I think today, IBM recommends separating out some nodes, some worker pool nodes into infrastructure nodes and running those type of workloads over there that you can license separately. That way you're only licensing the worker nodes that you have for those third-party tools and not licensing the ones that are entitled to you with Maximo. And last but not least, the platform new and old. And I think this is a kind of a key one as well, is not everything is going to shift overnight, right? You still have to maintain the current expertise you have, running those virtual and bare metal workloads, those cloud workloads that are supporting other applications, your version 7.6 application, the database platforms that you have for various other applications, as well as Maximo. All of those expertise and teams that you have in place for that are going to have to continue to evolve in their skill sets while you build these other ones. While you develop new expertise in the cloud platforms, the cloud services, the SaaS offerings, and all the different components that you're really adding in to build your Maximo environment today. Maximo is moving in a positive direction, moving in a cloud-first direction, moving in a hyperscaler direction where we can scale our applications, and that's huge. It's a huge improvement on the platform. It's a huge opening for all of us using the platform to run our business. But really, we're going to have to lean into it with IBM, help them enable us to do more with the platform, do more with the application, as we kind of figure out how all of these new applications that they've produced and that are part of our application suite and that we have access to really make us more effective in our industries. And with that, does anybody have any questions? All right, so I do have a few questions here I'm happy to answer. First one was around, can I run Maximo on something other than Red Hat OpenShift if I have a smaller deployment? I hear this question a lot. A lot of people that have smaller Maximo environments are looking to see what the suite can give them without really building out this massive cluster. There's a couple options there. You can do a POC with a partner. On-premise, typically, you're probably going to want to stay with OpenShift. We recommend running a single node OpenShift deployment or a Snow deployment. That's just a smaller, like I said, single node that you can set up and install mass in, so that you can kind of work through anything that your business might need to kind of test before moving to the suite. Otherwise, you can, like I said, go with a partner or a hyperscaler and spin up an environment out there on a on-demand basis to test out. Next one was, can you give an example of decoupling dependencies? So when I speak about decoupling dependencies, it's really about that shift in mindset, that more DevOps cloud-first approach, right? So, and we actually can see this with how the IBM teams are developing the application suite. So it's breaking apart all of these components that make up Maximo, that make up the tools we use to do our business, and then allowing their teams to develop, not necessarily in a vacuum, but with minimal impact, I guess, to other teams developing that platform. So, you know, the monitor team, while it's going to have hooks into, let's say, manage or mass core, they can kind of develop and innovate in their space without impacting those other teams. Next one I have here, what is on Project Tech's roadmap for other suite applications? So as I mentioned, or if I haven't, we do have some mass managed customers, mostly focused and managed today in our cloud, working through some commercial offerings around all the other suite applications. There's a lot of market applicability, a lot of business applicability, and we're kind of working through those as such. So as market viability kind of comes to us and market demand comes, we will be driving those POC efforts and R&D efforts on those I think right now we're looking at early next year for a few, so be on the lookout for those. But our goal is to really just iterate through all of them as we can. And I have one more here. How does DR and business continuity change with manage in the application suite? That's a good question. To kind of open it up wider, it kind of goes back into the slide where I talked about portability. You know, DR, business continuity, disaster recovery, all of that is really going to be dictated by how you build your solution. As you look to separate things out, maybe you use a cloud service for a component, maybe you're using VMs for half and bare metal worker nodes for another. You know, maybe you have a difference in how you're deploying your prod and your dev systems. That's all up to you. And that's really going to drive how your DR plan is going to change. You know, today you can run the exact same workload inside of VMs, DR over into that other data center, or do replication of those VMs that are your WebSphere application servers, your database, near real-time replication, and be up and running. You can do similar stuff with OpenShift. It's not really recommended. You'd be better off actually shipping that into another OpenShift container platform and kind of bringing the application up clean there. Like we kind of said about the consistency, that helps you in that aspect, right? Because you have that deployment, you have that operator that has all that configuration that's outlined. So being able to pick that up and put it somewhere else is actually one of the big benefits of the OpenShift platform. You know, spin OpenShift up on premise, spin it up in AWS, run those operators out there, and get a consistent deployment every single time because the platform's not changing. It's kind of the key. So I know that's not a holistic answer of how that's going to change, but I think it really comes down to your business, how you have Maximo deployed, how you're using it today. A couple more questions. Where are the databases? Where do the databases reside? So there's a few database platforms with the application suite. So as I mentioned, with Manage, you still have that relational database, the SQL, Oracle, DB2, whatever you're using today, or you can move as you go to the suite. Those can be run inside the OpenShift platform. They can be run outside on bare metal. They can be run in VMs, in a cloud platform, managed service. That, once again, is up to you. But there's also the Mongo component. Once again, that can be run in a variation of different ways. And then there's a Postgres database for the UDS service. And that, for the most part, that from what we've seen, most people run that in the cluster. It's pretty small, it's its own operator. But as with all of these, you can run them outside of the cluster. So one more here, if I can get to it. Is it possible to run, or is it possible to deploy multiple instances of Manage, IoT, Monitor, Health, and Predict on a single OpenShift cluster? Yes, it is. As you kind of deploy those and separate them out into namespaces, and then allow certain namespaces to interact, you can deploy multiple. Really, that's going to come down to the resources that those applications require. So, you know, let's take like MVI, visual inspection, for instance, requires a GPU. And so making sure that cluster is scaled correctly to run that workload and has the GPU count that is necessary for the deployed models and for the training that you need to do on those models is going to be key. So it's really just about right sizing the cluster for what you're trying to deploy on it. And I think that's all. Oh.
Yep, perfect. Thanks, Troy. We'll hop out of here and see everybody in the next session.
Yeah, thank you, everyone.